consider the linear functions. So as we have mentioned, linear function class is an example of algebraic function which the equation is composed of either a constant or maybe a product of a constant and a single variable. Just like for example this equation y equals x plus 1. Okay, as you can see, we have here the x as our variable and a constant which is 1. Okay, so this is considered to be already a linear function. If you could recall, class, a function is a relationship. Okay, a relation with the property that an input is related to one output. In our case, x here represents our input and the output will be the value of the y. Okay, so this is what we call relation or our function as we have seen. Now, a linear function class has a graph which is a straight line. Okay, when you see a line, that means its equation is a linear function. But take note, class, we have a vertical line, we have a horizontal line, we have a slant line, we have different positions of line. But take note that a vertical line is not a function. Okay? All lines except vertical, it is not a function. Later we will discuss why this vertical line is not a function. Now, a linear function class is an equation which is characterized by a slope and a y-intercept. Okay, there should always be a value of slope and a y-intercept. Slope class is symbolized as m and y-intercept is symbolized as b. Now, there are some books, class, that uses letter n to represent y-intercept, just like in your lecture notes. Okay, so generally, this is the form of our linear function. It is in a slope-intercept form, in the form y equals mx plus b. So your m there represents your slope, your b is your y-intercept. So obviously our variables here are x and y. X is our independent variable, while the y is the dependent variable, which means variable, it's not fixed. Okay, it could have different values all the time. Now our constants will be the m and the b, which means they are numbers. Okay, now what is the first thing that we can observe if that equation is a linear? How can we say it? If the degree is first power or the exponent, the highest exponent is 1. Okay? Or our variable x there is raised to 1, just like what you can see, mx plus b. So the x there, the exponent is in the first power. Therefore, we can say that it is a linear function. Okay? Now, like we have said, this function should have or should be unambiguous. When we say unambiguous, if the value or your input is x, there should only be one output, which is y. Okay? If the value of x is 1, and if you substitute it in the equation, so there should only be one output or one value. Wala na dapat na iba. Okay, and again, the graph of a linear function is a straight line, just like what you can see here, this one. So again, your m there represents your slope, while your b is y-intercept, or simply speaking, b or y-intercept is the point where your line, okay, the graph of your line crosses the y-axis. Okay, that is the value of your y-intercept. Where is that point where they intersect, or which it intersect with the y-axis? That's the value of your b. Okay, well, this slope, that is the gradient of your line. Now let us have an example here. Okay, so we have here a figure, okay, or two lines. The blue one, class, is the equation is y equals 1/2 x minus 3, while the red line has an equation of negative x plus 5. Now, if we notice, okay, based from our equation form of the slope-intercept form, the m there for the blue line is 1/2 here, as you can see here, this one. Okay, while your b is your negative 3. While for the red line, our m there, our slope, is this negative 1. Okay, or the coefficient of our x. While our b or our y-intercept is this. I'm sorry, kindly correct, this is 5. This is 5. I'm sorry, this should be negative 1. Kindly correct that, class. Okay. We have negative 1 and we have positive 5. Okay? So just by looking at the equation, you'll be able to determine right away the value of the slope and the value of the y-intercept. Even if you are just looking, class, at the figure or at the graph itself, you'll be able to determine the y-intercept. How? Just like this. Looking at the blue line, okay, where is the point where the line intersects with the y-axis? Now take note, this is our y-axis, this line here, the vertical line here. Now where is the blue line? This one here. So if you trace that, this is the point where it intersects with the y-axis. So what is that point? As you can see, that is between negative 2 and negative 4, which is negative 3. Okay? Now, how about for the red line? Here, as you can see, this is the red line, this is the y-axis. So obviously, this is the point where it touches or it intersects with our y-axis. So that is between positive 4 and positive 6. So obviously, that is positive 5. Okay? So again, the y-intercept or the value of your b is the point where your line or your graph intersect with the y-axis. So you only focus on the y-axis. Okay? Now, let's go back to the statement earlier that vertical lines are not a function. Why is that? Why is it that vertical lines doesn't have, or it is not considered as a function? Take note, class, that a vertical line doesn't have a slope. When we say slope, class, it is it refers to steepness, or it describes the direction of a line, or it could be steepness kung gaano siya how do you in an inclined or in an inclined road, for example, diba? Ganito yung natin, yung road, inclined. Okay, pataas siya. So the steepness is yung parang yung niya, gaano siya ka steep, or gaano siya ka, how do you define that in our vernacular? Gaano siya kataas, something like that, or gaano siya ka tirik? Gano'n ba yun? How do you define steepness in our term? So why is it that this vertical line is not? Okay? Because, class, the reason for that, one of the reason is that vertical lines has undefined slopes. Why is it undefined? Okay? Because, okay, for example, we have here a Cartesian plane. Okay? Just imagine this is a Cartesian plane. Now, in this Cartesian plane, let's say our equation is x equals 4. Okay? Now, so how are we going to graph that? Okay, this is our x-axis, right? So let's say this is our x where the value is 4. So how are you going to graph an equation which is x equals 4? This is how you graph it. Okay? Okay, so as you can see, if you graph a line looking like that, so all the time, okay, all the time, the value of your x is 4. Okay, it doesn't change. It's because it's stated there that x is equal to 4. So what does it mean? It only means that in every value of 4, as you can see here, let's take this part, this one. Let's use yellow, this one. Let's take at this point here. Can you see it? The yellow one. So let's say this is 4, and then the equivalent y is, let's say, 4 also. Okay? So our line, our point will become, let's say, 4, 4. Okay? Now, how about at this point? Let's say at this point right here, this one. Still, the value of x is 4, right? But then, if you trace, this is the value of y. Let's say this is, no, I'm sorry, this is negative 4. I'm sorry. This is negative 4. So let's say this is negative 4. Well, this one at the upper part, positive 4. So we'll have, kindly correct this class, this is negative 4. So the other one here is 4, positive 4. Can you follow? So what's my point? What's your point, ma'am? My point is, you have the same value of x here. This is x, right? And this second point is your y. You have the same value of x, but as you can see, you have a different value of y. Can you remember, I have mentioned earlier that a linear function must always be unambiguous, which means one input, one output, which means one value of x should only produce one value of y. In our case, there could have more values of y in just one value of x, because as you can see, class, this arrow indicates that it extends to infinity. So all values of positive y, or positive numbers, and all negative numbers, which is downward, in just value of x. Okay? This means that vertical lines cannot be a function. Okay? Because it follows the unambiguous term. So even if, like, for example, our equation is, let's say, x equals negative 3, the same class, we cannot consider it as a linear because it will still look like this. There. Okay? Although it has only one value of x, but the question is, does it have one value of y? So if the answer is not, then therefore it is not a function. Okay? So always remember that if the equation occurs in the form x equals c, then we cannot consider it as a linear function. Okay? So all vertical lines are not a function. Now, how about for horizontal? How about horizontal line? Is it a function? Now, in a horizontal line class, okay, let us draw something here. This is a horizontal. Let's use red. Okay, this is a horizontal. This is our Cartesian plane. Okay, let's draw a horizontal. Let's say this one. Let's say y equals 6. So let's say this is the 6 there. Let's say this is the value of 6. So this is your y-axis, right? So you just plot it. So this is your y-axis. So you just look for the value of 6 and then plot your straight line there. So all the time y is equal to 6. Now, as you can see, class, the slope is equal to 0. Why is it equal to 0? It's because, class, it's not, let's say, there's no steepness because it's flat, right? Yeah, and the slope, like we have said, is it describes the steepness of a line. Later we will be discussing the slope more. And as you can see, class, in this kind of situation, y equals 6. Okay? If you could recall the form or the general form of a line or a linear function is y equals mx plus b. Okay? There should be a variable. But in this case, only y-intercept here. Only the point where your line intersect with your y-axis, which is the 6. Therefore, your slope is 0. You follow? So in this, what do you call this? In this value, okay, in this kind of equation, can it be considered as a linear function? Okay. If you could observe, we have output, or this value of y is 6, right? Now if we pick one point here, like for example this one here, let's say x is 1 here. So what will be the value of y? So if your x is 1, the value of your y is 6 there. Now what if your value of x is -3 there? What will be the value of your y? It will be still positive 6. Can you follow? So, can we, or is it possible that it can be considered as a function? Yes, class. Okay? It is still considered as function because we have a different input, right? We have a different value of x. You have 1, you have -3. There's no possibility that there's an equal value of x, just like, or if you compare it from the previous one with the vertical, we have the same input but different output. In this case, different input, okay, the same output. So it could be, or it is considered as unambiguous. Okay, so therefore we can conclude that horizontal lines are considered as a function. Okay, so that's how we describe the line. Okay, now let's dig deeper with the slope. Slope, class, like I've said, is symbolized as small letter m, and it describes the direction. Okay, it depends on our sign. So if for example we have a negative, we have a positive, so it will indicate direction. So kanina, positive 1/2. So positive 1/2 will tell us what's the direction of the slope, or the line rather, the graph of the line. Well, the negative will also tell us what will be the direction of our line. Also, class, the steepness, when say steepness, it refers to the magnitude of our line, or the slope rather. For example, 1/2, that is the magnitude. The negative or the positive refers to the direction. Okay, it could be downward, upward, somewhat like that. So how are we going to determine or to solve for the value of our slope? Always remember, class, that slope is rise over run. Okay, it is somewhat our mnemonic. Rise over run means rise refers to the value of your y, while the run refers to the horizontal rise over run. So which means that in order to solve for the rise, it refers, class, to how much point did he go up or down. Okay, it refers to how much, or how much, or how far did he go up or did he go down. And we may only be able to solve for that by subtracting the previous point to the new point. Okay, just like our formula there, y sub 1 minus y sub 0. So your y sub 0 is your previous point, and then y sub 1 is your next point. Again, how the y refers to the vertical point only, or vertical distance only, while the x sub 1 and x sub 0 are your horizontal movement. So your x sub 0 is your previous point and your x sub 1 is your final point, for example. So all you have to do is subtract that in order to determine the change in the position, okay, or in the distance, to get the distance between the 2 points. So you simply get the rise over run to get the slope. Okay? Now, here are the graphs of a line. Okay? It could be upward, it could be downward, or it could be horizontal. Again, the vertical is not considered as a function because, like I've said, it is undefined. Okay, so if, for example, your line is going up or like this, as you can see, we can consider it as going up if it is inclined to the right. Take note, class, here. It is inclined to the right. See? Okay, let's use bolder color. Let's use red. This one. See, it is inclined to the right. So that means it is positive. But if it is inclined to the left, it is going here to the left. Inclined, which means it's like sleeping on the left, is negative. Okay? So when you solve and then your m is negative, so expect that the graph of it is inclined to the left. Okay? But if the slope is 0, which means that the graph is 0, or is horizontal rather. Okay, but if it is undefined, it is vertical. Now, class, when does it happen that our slope becomes 0? Again, what is a situation that our slope becomes 0? Class, it only happens if there is no changes in your vertical position. Okay, there is no changes, which means your rise is equal to 0. If you could recall, class, diba? If the fraction is like this, 0 divided by a number, let's say 4, what's the result? 0, right? So 0 divide any number is still equal to 0. So again, horizontal graph or a slope of 0 only happens if there's no changes in your vertical. Okay, in your vertical. But vertical line only occurs if there's no also changes in your horizontal. This is because, class, undefined only happens if you divide a number by 0. Okay? So if your denominator or if your x sub 1 minus x sub 0 is 0, or your change in the horizontal is 0, so that means your function is undefined, or your graph is a vertical. Okay? So that is all about the linear functions.